Welcome to the triangle midsegment theorem. Today's objective is to prove and use properties of triangle midsegments. Let's first come to a definition of what exactly a midsegment is, and it's very similar to what it sounds like. A midsegment is a segment that joins the midpoints of two sides of a triangle. So a midsegment is a segment that joins the midpoints of two sides of a triangle. So if I go to my triangle right here and I come to this midpoint and this midpoint, we call this segment right here a midsegment. So we would call this midsegment AB. Now if I draw one on the other side and connect those, and then I connect the ones across, I have what's called a midsegment triangle. So the midsegments in this diagram are segment AB, AC, and BC. And the midsegment triangle would be known as triangle ABC. Now midsegments have a certain property for their distance and their length, and especially to see how they correspond to other sides of the triangle. And we're going to explore those. Let's examine midsegments and see if we can come to any conclusions about the properties of the midsegments. In this diagram, we have two midpoints, K and L, and I want to first start off by finding the third midpoint of side GJ. So I want to find the midpoint of segment GJ. Well, I know all I have to do is take the average of the x values, -7 plus 1 divided by 2, and -2 plus 2 over 2. When I do that, I have -6 over 2, which is just -3, and 0 over 2, which becomes 0. So my last midpoint is right here. And we'll call this P. So now I have my midsegment triangle. And what I want to do is I want to compare the slope of KL and the slope of GJ. So the slope for KL would be the change in y over the change in x. Now KL here is 1, 2, 3, 4, 5, 6. So -6, comma 2. And L is -2, 4. So the change in y would be 2 minus 4. The change in x would be -6 minus a -2, so we make that plus. So we have -2 over -4. So the slope of KL is just 1 over 2. Now let's find the slope of GJ. So we already know the points, so we're going to find the change in y over the change in x. So that gives us -2 minus 2 over -7 minus 1. So we have -4 over -8, and we have 1 over 2. So we have identical slopes. Now this is going to work out for every single midsegment. So the first part of the midsegment theorem that we want to talk about is that midsegments are parallel to a side of a triangle. So this is the first part of the midsegment theorem. Now the second part of the midsegment theorem has to do with the length. So I'm actually going to erase everything that I've written on the slide and show you guys the second part of the midsegment theorem. Let's examine the lengths of KL and GJ. So examining the lengths of KL and GJ means we have to use the distance formula to find the lengths. Now remember, the distance formula equals the square root of the difference between the x value squared and the difference between the y value squared. So we're going to use this formula to help us find the lengths of these two segments. So first, let's find the length of segment KL. Now to find the lengths, we need the endpoints. So the endpoints of KL are -6, 2, and -2, 4. So let's use the distance formula to find this length. So to find the length of KL, we do -6 minus a -2 squared plus 2 minus 4 squared. Now when we do this out, we have -6 plus 2 is -4. -4 squared is 16. 2 minus 4 is -2. Minus 2 squared is 4. So the length of KL is the square root of 20. Now for GJ, the endpoints were -7, -2, and 1, 2. So the length of GJ is going to be -7 minus 1 squared plus -2 minus 2 squared. We simplify this out. We have -8 squared, which is 64, plus -4 squared, which is 16. And if we add these together, we have the length of segment GJ is the square root of 80. But what we want to do is we want to simplify both of these radicals. Now if we simplify the radical of square root of 20, we get the square root of 4 times the square root of 5, or we have 2 square roots of 5. When we simplify the radical of 80, we have the square root of 4 times the square root of 20, and we know the square root of 4 is just 2, and the square root of 20, we just figured it out from right here. This is 2 square roots of 5, or 4 square roots of 5. So if we notice here, the length of GJ is 2 times the length of KL. And that's going to be the second part of our midsegment theorem. So the midsegment theorem says that a midsegment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. So, if I have my triangle here, I have side A, B, C, and here's, I'll say, my midsegment DE. So, first thing I know is that DE is parallel to AC, and now I know that the length of DE is half the length of AC. Or you could think about it this way. The length of DE multiplied by 2 equals AC. So this here is the information for our midsegment theorem. We proved that DE was parallel with AC by comparing the slopes, and we proved that DE is half of AC by using the distance formula to find the lengths. So let's practice using the midsegment theorem. So first thing I'm looking for is the length of UW. So UW is a midsegment, and I can tell because here it's the midpoint, U is the midpoint of side RS, and W I know is the midpoint of side RT. So I know that UW is going to equal half of its parallel side, which is ST. So I see over here that ST is 7.4. So to find UW, I do 1/2 of 7.4. And I calculate that out to be 3.7. Okay, part B wants us to find the measure of angle SVU. Angle SVU is located right here. So what I know from midsegments is that this segment right here is parallel to this segment right here. Now if I think of UV as a transversal, I can see that this angle and this angle have to be congruent because of alternate interior angles. Therefore, angle SVU has to be 41 degrees. And that'll be the end of the video. Thank you. Take care.